Hello, my name is Erik Rademacher Fleitz, and I'm the Crosscut Saw Coordinator on the Shasta-Trinity National Forest in Region 5. I'm a trail crew leader and wilderness ranger, and in the winter I sharpen crosscut saws for any Forest Service units that can pay my time to sharpen their saws. Currently, I spend a lot of my time training new crews to be crosscut sawyers and training people on how to sharpen crosscut saws. I've been doing trail work for about 15 years, and over that time I've learned that with proper training and sharp saws, crosscut saws really are the best tool for the job of remote trail clearing. Early on, I learned the hard way that without having a sharp saw and a few good tricks up your sleeve, these saws really can be inefficient to use. So my mission now is to pass on the knowledge that I've gained over the years to help newer sawyers get started on the right foot. The Wilderness Act of 1964 was passed to retain some small parts of our country in a more pristine and natural state. The common denominator of increased human manipulation of the environment was mechanization. Congress decided to designate wilderness areas as a place where humans don't live full-time and where mechanized tools and transport were limited. In wilderness, we wouldn't have the modern conveniences and the tools that enable us to manipulate so much of our landscape. At the time that the Wilderness Act was passed, many trail crews working in remote areas that became wilderness were already using crosscut saws, so those saws became the designated tool for the job of wilderness trail clearing. Keep in mind that just 10 years before the Wilderness Act was passed, crosscut saws were still one of the main tools being used on logging sites around the West. Power saws were being used on flatter ground and for most bucking, but into the mid-1950s, most falling of large trees on steep slopes was still done with crosscut saws. Crosscut saws are also useful in environments where loud noises should be limited or where there are pollution concerns. Crosscuts are quiet and use much less oil than a chainsaw. They also make a good training aid for crews to really be able to hear, see, and feel how wood reacts as a saw cuts. Now, there's no doubt that a well-maintained chainsaw will slice their wood faster than a crosscut saw. But most wilderness trail work involves long miles of hiking, and work is spread out all along the way. My crews here tend to hike an average of 55 miles a week, carrying all their tools, and they cut between 80 and 120 trees off the trail in that period. Hiking with a well-balanced 8-pound crosscut saw is much faster than hiking with an awkward 20 to 25-pound chainsaw and all its accompanying fluids and gear. On long-range work trips like this, sharp crosscut saws are probably going to be the faster tool for the job. This has been studied several times, and the results of each study was that in backcountry trail work, crews who used chainsaws did not generally get more work done than crews using crosscut saws. Sometimes there is a major backlog of logs to be cleared in a small area. Sure, a chainsaw would likely clear that faster. But the Wilderness Act values the untrammeled nature of wilderness, which sometimes means that we won't be using the fastest tool for the job because of the stated value of humans not being the dominant force in the wilderness environment. Let's head down to the Weaverville Ranger Station and talk about maintaining and sharpening crosscut saws. Welcome to the Crosscut Saw Filing Shop at the Weaverville Ranger Station. We have no designated funding for our crosscut saw training and maintenance program, but there's such a demand for saw sharpening and training that many forests fund my timesheet so I can sharpen their saws or train their crews. I learned to sharpen crosscut saws by attending several classes with Dolly Chapman, and that's when my interest in saw sharpening really took off. Now, Dolly and I each teach 4-day saw sharpening classes, and we often team up to teach these classes together. There are also several other training opportunities around the country that take place periodically. These classes are the best way to learn how to sharpen crosscut saws. A saw filer always completes every step of the process. There's no such thing as a touch-up of a crosscut saw. All the measurements are made to the thousandth of an inch, and any variability, even by 1,000th, will affect how the saw runs. You cannot sharpen between tunings without messing up these measurements. It usually takes me between 20 minutes and an hour per foot to sharpen a crosscut saw, depending on its condition. Most high-quality crosscut saw manufacturing stopped in the mid-1950s, and most of the saws we sharpen are from before this time. so they're now antiques and need to be treated carefully. This here is a Simon's 513, one of the highest quality falling saws ever produced, and a very common saw on trail crews. This one has been previously filed by me and is in for a resharpening. Most crosscut saws in trail work are called Raker tooth saws, and they have two different types of specialized teeth. Unlike a plain tooth saw, which has teeth that both cut and rake out the material, crosscut saws have two different types of teeth, and each tooth is specialized for a specific purpose. This is why they're so effective when tuned correctly. These are called the cutter teeth, and they're designed just to cut parallel lines down the outside of both edges of the saw kerf, scoring the wood but not removing anything. These are called the raker teeth, and they come in at a right angle to the parallel cuts made by the cutter teeth and act like a planer blade to remove a strip of wood scored by the cutter teeth. A well-tuned crosscut saw in solid moist wood should be putting out strips of wood called noodles. If a saw is just spitting out sawdust, then it's probably dull. In drier woods, it should still be putting out noticeable pieces of noodles, though they may crumble more quickly. That raker tooth also has a second purpose. Each forward-facing raker acts like the planer blade, but each backwards-facing raker acts as the depth gauge, keeping the saw from digging too aggressively into the cut. The raker tips take turns filling these purposes as the saw changes direction. This is why pushing down on a crosscut saw does not effectively increase its performance. A trail crew saw filer sets their raker tooth so the saw has a balance of being aggressive while still smooth enough to run for a full day's work. The first step of sharpening a crosscut saw is cleaning the saw. In a well-ventilated area, excess oil and grease can be removed with a rag and kerosene, and built-up pitch can be similarly removed with whatever solvent you prefer. Rust can easily be removed with a natural or manufactured pumice stone and some water. Never clean a saw with power tools. Some of the worst damage I've seen done to saws is from an orbital or belt sander, as they can very quickly introduce negative set into the cutter tips, and they will also scratch the harder outside skin of the saw and mess with the saw's flexibility. Now that the saw is clean and smooth, we can check it for straightness. Many saws have bumps and bends that you may not be able to see with the naked eye, but if not straightened, they will worsen if you keep using it. Also, these bends will make the saw filer's tuning job less accurate. To check for straightness, you hang the saw from one end, and then you take straight edges, and you run the straight edges up and down the saw and look for bumps and mark them. Then you head over to the straightening bench to straighten the saw. Saw straightening is done by putting the saw on a hard, smooth, and flat surface and hammering on it with either a cross-peen saw filer's hammer or a polished, smooth, single jack sledgehammer. And you straighten by hammering on the saw where you marked where the bends were. And then checking for straightness. Your final check for straightness should again be done by hanging the saw and measuring it from both sides. Next, you assess the teeth of the saw to get an idea of any major issues with the saw's tuning. I run a flat edge down the saw to check for high and low teeth, and then run it on either side of the saw to feel for under or overset cutter teeth or bent rakers. This saw appears to be in pretty good shape, but the measurements that I'm going to tune it to are smaller than what my eye can see, so undoubtedly it will definitely need a full tuning if I'm going to resharpen this saw. The first step of the actual tuning of the saw is called jointing the saw. And these old saws were made with all the teeth along a true arc, or a segment of a circle. When you're sharpening, if some teeth are higher than the arc of the saw and some are lower, then they won't all work together correctly. Also, as a saw wears, it usually wears more in the middle third, so the arc can flatten over time. Jointing the saw is how we realign all the teeth so they're all, again, along that true arc. We use several tools to joint the saw. These two tools are called short jointers, and they're basically a jig that holds the file at a right angle to the plane of the saw. When you run the short jointer down the saw, it only files the taller teeth, so you can file until every tooth has a small flat spot on top, at which point you'll know they're all smoothly in line. The short jointer, however, cannot measure the true arc because it only measures one point in space. If a saw still has a true arc, or you want to bring back the original arc, you'll have to use a long jointer to measure the true arc. This long jointer has a file and two shoes that are adjustable that can be set to define a true arc, because 3 points in space make a curve, and if they're even, it's an arc. Once set, you can use the long jointer to measure and file only the teeth that are higher or even with the true arc until all the teeth are on that arc. To set the long jointer, you loosen these screws, place the tool on a spot that has the true arc, and then tighten down the screws. From here you can test to see if the saw has a true arc, and you can use it to joint that arc if you need to. It's often best to use a long jointer and a short jointer in combination to achieve your goal. After assessing, I can see that this saw has only worn down a few thousandths of an inch, and when checked with the long jointer, it still has the true arc. So in this case, I need to do a very light jointing, which I'll do with a diamond plate on another short jointer. I then check with reflected light to make sure that every cutter tip now has an almost microscopic flat spot on the tip. And to be extra clear, or extra sure, I can now place the long jointer back on to measure and make sure that I'm still in that true arc and that I didn't mess it up with the short jointer. Next, we tune the raker teeth. The tuning will consist of swedging the raker, which is creating the curved shape that will help the raker pull itself into the wood and gently lift out the noodle. The rakers are also swedged lower than the cutter teeth. Wood has a slight springback effect because it's a resilient material, so the cutter teeth must cut deeper than the raker so the wood springback does not cause the raker to cut into wood that has not yet been severed. First, I take a triangular file of the correct size for the saw and file the raker V deeper and thin the raker tip until I think it's the correct thickness and shape to bend the swedge. But I have to be careful not to overfile and lower the raker tooth. Then I take a specially designed hammer hammer on the raker tooth at just the right spot to bend it without breaking it. Then I measure with a raker gauge tool like this one. The pin on the tool tells me how much more I need to swedge the raker. I use a combination of filing the inside face and hammering to get the tooth to just the right height and shape. And sometimes I file from underneath with a round file to remove excess swedge. Once the raker is swedged, you file it to its final height using a raker filing plate, and that's located on the other side of the raker gauge tool. The plate is set 2/1000ths of an inch lower than the pin that we swedged to, so the raker tip sticks up slightly above the raker filing plate. This leaves a hair-sized flat at the raker tip. This flat does not impede the saw cutting into the wood, as the actual cutting angle of the saw is diagonal with the force of the pull, not directly down into the wood. However, any excessive flat spot should be removed at a 15-degree angle until only a hair of flat remains. Now we'll work on setting the teeth. If a saw only cut a kerf as wide as the saw, it would immediately bind up because of the wood springback effect. Also, a wider kerf can be desirable because it can give you more time to cut into the wood with binds so that you can get deep enough to get a wedge in. Because of this, we put set into the teeth, which is bending the tips of the cutter teeth outward in alternating directions so they cut a wide enough kerf. Many older saws have what's called taper grind, which means the spine of the saw is ground thinner than the tooth edge. These saws still need set, but the amount will vary based on the taper and the type and shape of the saw. Modern flat ground saws need much more set than vintage taper ground saws. To set teeth, you'll need a hand anvil, the other side of that saw sharpening hammer, and a spider set measuring tool. To set the teeth, you usually place the hand anvil about 3/8 of an inch below the tip of the tooth and smack it with the hammer to cold forge it outwards. You don't want to simply bend the tooth or it will likely break. It's important to be forging the tooth rather than bending like a diving board. This saw, I know from experience, has micro cracks in some of the teeth that are right about 3/8 of an inch below the tooth tip, and that is because somebody in the past bent the teeth too much while setting. Because of that, in this case, I'm actually going to bend the teeth, well, forge the teeth, closer to a 1/2 inch down the tooth. Then you take a spider tool, which has 3 feet of the same length and 1 foot that's shorter by the desired 1/1000th of an inch. You place the 3 equal length feet on the body of the saw and then feel the tooth tip with the shorter foot. If the spider rides up on the tooth, then the tooth has too much set, and if there's any air gap, there's not enough set. The spider should sit firmly and smoothly on a correctly set tooth. I don't know if you can hear that clicking sound. That means I need more set. So far, we've really only been tuning the saw. Next, we actually sharpen the teeth, which is the step that most people imagine when they're thinking about sharpening a saw. The tuning really takes 80 to 90% of the effort of filing a saw, and the sharpening is just the finishing touches. This is also the part where well-intentioned people often do the most damage to the saw. They may pick up a flat file and just point up the teeth, but in doing so, they're changing the arc of the saw, messing up the tuning of the saw, and often creating an unsustainable tooth shape that'll be very difficult to repair. To sharpen the teeth, you slightly angle the saw towards the source of light so you can see all those tiny jointer flats on the tip of all the cutter teeth. You then begin to sharpen down at the shoulder of the tooth and file upwards and rotating the file to create the desired tooth shape. This is more difficult than it appears because you're using a flat surface to file a rounded almond shape onto a surface that's already rounded in a different direction from the set in the tooth. You also want to be sure that a burr does not build up on the back edge of the tooth, as that can be deceptive and make it look like the tooth has more metal than it does. As you file, watch those tiny reflective jointer flats, because at the end, you want to leave the smallest amount of that flat as you possibly can. If you leave too much flat, the saw won't slice in as well, but if you completely remove it, you've lowered the tooth a bit, and your tuning measurements for the adjacent raker will become smaller, and about 90% of how a saw runs is in the last 10% of precision, so we really want to keep all of those cutter teeth on the arc of the saw. At this point, you have a sharp and tuned saw and you're ready to go. Now that you have a freshly filed crosscut saw, you want to keep it as sharp as you can for as long as you can. Here's a few tips on keeping these saws sharp. Always use a light amount of oil and solvent on the saw to keep the saw running smoothly, not overheating, not rusting, and not having pitch build up on the saw. I prefer diesel fuel as a lubricant, and I only use about 16 ounces for a full week of trail work, just enough to keep the saw gently coated during use. Also, you need to remove bark from trees. Bark not only holds onto dirt and dust, but it's also more abrasive on the saw in general. You also want to avoid cutting knots when possible, and definitely never run the saw through the dirt. You want to transport the saw with a tooth guard on and keep it in a safe location while working. Don't let the saw bounce around in the back of a truck with other tools. And then clean and oil your saw after every day's work, or more often if you're working in the rain. That's my 2 cents on crosscut saws and saw filing. There aren't very many saw filers left out there, so I encourage anyone interested in learning to reach out to me or find someone in your area who can teach you more about the saw filing process.